What's up, what's up, what's up? Welcome back. Today we're working on my terminal emulator. Termi, we're calling it. Terminal emulator. You know, he's got a little bit of like a pun in there. Maybe pun's not the right word, but you know, we've got a title. And the idea is that there's lots of things about terminal emulators that I feel like I don't really understand. And so, in typical Mick fashion, we try to write that thing to expose the details, I guess. So where we're at right now is not this window, maybe this one. Sorry, I don't have the thing open right now. But where we're at right now is we have a terminal emulator that like we launch, it spawns a shell, a really basic shell because we were worried about like not supporting enough features to run bash correctly. And we have input and output, so hold on, let's just give it a sec to launch. I thought it would be up and running, but here we go. So we have this shell, right? We can like type stuff into it. We can type like ls, we get some stuff. We can type like echo hello world, and like that does something. So we've got like kind of like the basics down, but if we start doing anything more advanced, like we try to run like our editor, it's just like, what the fuck is this, right? Like there's a lot that we haven't implemented yet that makes all this stuff not work right. And so that's what we want to look at today is maybe try to handle a basic case of some of these like escape codes, they call them. So the idea is in order to interact with the terminal, basically everything is just like a bunch of bytes going over some like file descriptor. So you have like your terminal. Okay, we'll draw it like this. We have like the kernel. The Linux kernel is down here, and he has this like special device that he creates for every terminal that's run. Every shell that you have open is a like, I think it's a pseudo terminal device that's like connected to a like TTY, I think, or something. Teleterminal window. I don't remember what it stands for. But these are like kind of like relics of the olden days where you had a physical terminal that had like a keyboard monitor plugged into it that was like plugged into the computer. And over that thing, you would send like, you know, you'd have like your terminal window over here, and he would be like showing like some stuff on him, right? He'd have a physics console. And if you wanted to like type stuff into him, stuff would physically go over the wire. So you would like, he has the display and the keyboard. So the keyboard would like come and it would like plug into this, I guess. And it would like come over this connection as just like series of things that were pressed. Or I guess maybe the other way around. Maybe the keyboard... I'm a little shaky on the details here. But the way that it's implemented in software, at the very least, is that like the terminal emulator acts as if all he can receive is like a bucket of bytes that comes over this connection. So you have like bash is over here, and he sends stuff to this like pseudo terminal, and the pseudo terminal is connected to like the window through this thing. And so what this ends up giving you is like essentially, in order to do cursor control, there's no like connection like this, right? There's no like direct connection here. Bash can't say like, hey, terminal emulator, put the cursor here. What it has to do is it has to say, well, I can only send like characters over this thing. So what if I send like a super special secret character that says, put the cursor in this position? And then I can send another one that's like clear the screen or something like that. And there are all these like escape codes, ansi escape codes, that are like special characters that define actions that you can take in the terminal. And so when I type clear in this guy, if I type him here, that like resets my screen. But if I do it in my terminal, I get this like hunk of garbage here. And so I think the goal for today is to try to get this command working correctly. And that will, as a side effect, mean that we've parsed ANSI escape codes in some way, shape, or form. And so I think the plan of action here is to like first try to like parse the escape codes at all and not really handle them. Just make sure that we like get them. And then we can start looking at what codes are coming in and try to handle those ones correctly. Either clear or the bell escape code. Dude, I can't, that fucking bell, it pisses me off so much. Uh, I think on my laptop for a while, it was like hard coded to the speaker, even if my headphones were plugged in. And so I would just like backspace in my shell and just get like beep, 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 beep. And I just like couldn't fucking turn it off for a while. And like, there's like some command you have to like give to your system to be like, please, please, please don't beep when I just type characters on the keyboard. But yeah, that's just annoying. Okay, so let's start looking at general ANSI escape code handling. What does that mean? So there's this useful little gist on GitHub that has a big list of them. But I think probably what we're interested in is things starting with this escape sequence, 0x hex 1b. So if we get the character 1b, we might be in an escape sequence. And then probably after that, I'm assuming that we're going to see some sort of like reset cursor to position. Let's see if there's like cursor controls. Yeah. So here they run the like escape code, which is 1b, hex 1b, and probably they're like put to home position, and then maybe they like write a bunch of stuff. I don't really know. We'll see. Oh, erase and display. Yeah, nice. Okay, maybe we'll see. I guess exit doesn't work either. We'll have to get to that at some point. So let's get in here and just maybe we'll start looking at. Okay, where we get input from the thing somewhere, and when we read our input from the terminal, we update our cursor position, and we also update like the output of everything that's happened so far. And so I guess one of the things that we're gonna have to do in here is we're gonna have to like parse an ANSI code. I don't really know what that's gonna look like yet, so maybe we just start by doing like having nothing come out of that, but we'll write a function that looks for the ANSI codes, and maybe we'll just log them for now. Maybe. So this is gonna take in like a incoming byte slice. Okay. And he's gonna output nothing for now. Certainly later he's going to output something because we're probably gonna want to switch behavior if we get an escape code, but that's fine. And what is the like sequence here? So if you get an escape, how do you know when the escape ends? It looks like there are like flag characters. Is there like an ANSI escape code specification where we can read what like the expected behavior is? Okay, almost all users assume some functions of some single byte characters. Oh, okay, so this is like backspace and shit. Okay, that's not really what I'm worried about right now. Escape is followed by a byte range in 0x to 5f. The escape sequence of type FE. Its interpretation is delegated to the applicable C1 control code standard. Okay. So what does FE mean here? But it looks like each of these just have one. Oh, I see. Control sequence introducer starts most of the useful sequences terminated by a byte in the range 0x40 through 0x70. Okay, I see. So we're gonna probably see a bunch of stuff that starts with the escape code, then this open brace, followed by a bunch of other shit. Okay. So I guess let's just start for looking for. Maybe we look for the escape code. So if incoming, how do we want to do this? I guess, right now we're kind of like pushing everything into this buffer. But I guess ANSI escape codes might be multiple bytes long, and they might not all come, the whole escape code might not come in like the same read call. Right? If our read call says, hey, I just got like 10 bytes, and the 10th byte is the start of an escape sequence, we kind of need to like handle that in some way. So maybe like an ANSI input buffer maybe is how we want to call this. And this guy is responsible buffers input until end of control sequences. Okay, sure. And then he's gonna have like some characters that he's pulled in, right? And maybe he's going to be a double-ended vector because we're going to be pushing characters in and then popping them out the front depending on like you. No, we can use it as a vec as a whole. So we can say that we accumulate stuff, and as soon as we think that it's finished, then we wipe the whole buffer and send that on to the actual output. That seems reasonable. Okay, and that's probably all we need. So then we can say impl input buffer, and we're gonna say push, and we're gonna push in maybe like a single character. Or we can push in a slice maybe. So you can say push in incoming data is this, and he's gonna return a vec u8. So he's going to say, hey, when I am ready, I will return, you give me some bytes, and I'll give you back the ones that I think are relevant. Sure. That seems reasonable. And maybe is vec u8 here really what we want? I guess like we might want to return an enum here of like terminal output. I guess input buffer is kind of wrong here. Maybe output buffer. It depends on if what we consider input and output. This is the terminal output, but it's the input to our state. But we'll call it output buffer. That seems fine. That seems fine. And so here the output will either be like ansi, I don't know, like an ANSI chunk of code, or sorry, like an ANSI sequence, or we're going to come back with data. And if someone pushes us some bytes and it has both of those in it, then we actually have to return a sequence of these. Right. And maybe we want to actually refer to these as slices. We can say that like, hey, we had some input data and we'll return you chunks of that stuff back, except for in the case where we had like ANSI code split across several pushes. This doesn't work anymore because we can't give a contiguous slice of something that we held and something that they gave us. So slices don't make sense here. Vec, I guess, does make sense. And then I guess we just return maybe a vector of terminal output. So then we might get something like set color to red, and then like some text, and then set color back to default, and that will all be in like an array of some form. Yeah, that makes sense to me. That makes sense to me. Okay. So what's he gonna do? He is going to start by looking for that like 1B. And probably this needs to be like a byte string of 1B. Maybe this is a single character like this. Okay. And you can say for byte in incoming. We have our like data output is a vector, and we have our buffer is already stored here. Okay. So we can say first if our buffer is empty, we do like normal parsing. We do normal stuff. But if we are already, if our buffer isn't empty, then we're like in the middle of parsing an ANSI escape sequence. So here we can say parsing ANSI escape sequence. And we're just looking for a terminator, I guess. So maybe a buffer here isn't even like maybe the most reasonable thing. Maybe we want our output buffer to be like a partially constructed ANSI code. We call it like current state ANSI builder or something. And we can say like enum ANSI builder. And here we can consider this like our state machine of some sort. Right, so we'll start with it being empty. Okay, and if we get the escape code, we'll say that we are in the like escape state. Escape code. Escape. And if we're in the escape state, then we're looking for like one of these next characters. And from each of these, we'll like move into another state. So I think that makes sense. That makes sense. So we'll say match self current state. And if we are in ANSI builder empty, the only thing that we need to worry about here is if the thing, if we're at 1B, then we switch to the new state. So I wonder if it makes sense to do like the loop on the inside or outside. Maybe like, do we want to match our current state on each byte? That makes sense because that allows us to switch states between bytes, but it does seem like maybe inefficient, but maybe we can come back to that if it becomes a problem. Because certainly it won't be. Okay. So now we can say if the byte is 1B, then what? If it's 1B, then we just set our current state to ANSI builder escape and continue. Otherwise, we push the byte into our output. Okay. And maybe what we do for now is if we're in an escape, we don't handle anything right now, so we just say panic unhandled escape sequence, and we just log the byte here. That makes sense to me. Sure. Fuck it. And then for now, we just return a vector that has our terminal output data of the data output. Okay. That seems reasonable for now. Consider dereferencing this borrow. Okay. And we're chilling. So all we have to do now is here, we need to store a output buffer. And here we say output buff is output buffer new. We have to make a new function. And in here, we just return output buffer with current state is ANSI builder empty. Cool. This needs to be mutable. Okay. And then here, just every time we come in, we say self.outputBuff.push incoming. And we say let parsed is equal to this. And for segment in parsed, this seems reasonable so far. For segment in parsed, we match the segment. And this is the normal case. We have, I already forgot what it's called, terminal output data. We do whatever we were doing before. And if we have terminal output ansi, we go, I don't know what the fuck we're gonna do yet. I don't know what to do. And here, instead of using income here, we could use the parse data. Boom. All right. Let's see if that runs. Somebody is asking for the GitHub. I'll just quickly copy paste that in chat if you're curious. There you go. And it looks like we are still running. And now what happens if I run clear? We panic like expected, and we see unhandled escape sequence 5B. Okay, so we're on a good path. So 5B is almost certainly this guy, but we can look at like the ASCII table and see if we can if 0x5b is one of the things in here. 5b, and it is the open bracket here, like we saw in here, which is good. Which is very good. So now we can just say, we can just start handling that case, I guess. That makes sense to me. So this guy is called control sequence introducer. So we'll just say that we're now in the CSI state. And we have all of these fucking sequences to deal with now. Okay, cool. Seems fine to me. We can just kind of start, we'll just kind of like start typing, I guess, and see what happens. So, depending on the byte that we get in, we are going to do something. We're going to do something. But here we know that the only thing that we have to worry about right now is the CSI. So we'll just say, if we get this, we say self current state is equal to ansi builder CSI. Okay. And anything else, we just say we do this panic that we were doing before. Okay. And now here we have ansi builder CSI. And here we do the same thing, but instead of unhandled escape sequence, we just say unhandled CSI sequence. Seems simple enough. Seems simple enough, and we can just run that and see where it fucking breaks. Unhandled CSI sequence 48. So that's a really good sign, actually. We got to the point where we handled the escape and the control sequence introducer. We parsed those correctly, and now we are seeing a 48. So what the fuck is that? Maybe we should try to print the ASCII character as well. So maybe we say, we'll kind of log it like this. And here we'll say, maybe we'll do that on this one here. So here we log something, and then we put the other thing in the hex version of it in brackets, and we try to say, what? There's probably some like ASCII shit in the Rusdown library, right? Certainly. So can we like ASCII X use inherit method instead? Is there like, maybe we just try to cast it to a car? Yeah, car from U32. Is there from U8 from U32? Oh yeah, okay, we'll do this. Let printable is equal to stood car from U32, and we pass in the byte as U32 here. And I guess we'll just print it debug like this. That seems reasonable. That's reasonable. Let's see what that prints. Let's see what that prints. So he says now, we tried to write an H. Nice, that's great. That's great. So that should make my life easier now, because now we can just go back to this Wikipedia article, and we can look at the H here. And it says, moves the cursor to row N, column M. Is what we're supposed to see here. The values are 1 base and default to 1 if omitted. Okay. A sequence such as CSI blank semicolon 5H is a synonym for CSI blah, 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 blah. Okay. So it looks like these are both optional, I guess. So maybe in here, we're going to say start, and end is what we're going to store in here. And there's actually 2 states here, right? There's one where we're parsing the first the start thing, and after we see a semicolon, we've like switched states to seeing the end. So maybe we actually want like another like CSI parser, and he can be in one of the states of like start, or what are they called? Row and column, or finished. Okay. That makes sense to me. And so we can say like impl CSI parser. And here we're going to say function push, and we're going to take in mutable self and only pass it push into byte this time because that's how the parent is using it. And I guess here, if we are in the row state, so what? We are in the row state. In this case, we match the byte. No, we're not going to do it this way. In any scenario, if we see the H, we just move ourselves into the finished state. Self is equal CSI parser finished. Okay, makes sense. We actually have some state associated with each of these guys, though. So this is going to be CSI parser state, and we're going to have a struct CSI parser, and he's going to have a state, which is a CSI parser state, as well as a row and column. Okay, makes sense so far. We're going to, when we construct this guy, we're going to start him with a CSI parser with an empty state, or a row, state of row. So CSI parser state, he's going to start in looking for the row, right? Because that's what this says. The first thing we look for is the row. Then we're going to look for the column, then finished. Our initial row, its default should be 1, and column should also be 1. Okay? And this is fine so far. Now when we push this, we say self.state is now updated. And if the state is finished, we shouldn't exist anymore. We should never be called with the state of finish. So maybe we say assert self.state is not equal to CSI parser finished. I don't know. Derive EQ and partial EQ. So we can do that. CSI parser state. Oops, like this. Hey man, are you making a roast terminal emulator? Yep. That's what we're on today. That is what we're on today. Here we should be matching self state. If you don't want to parse the ANSI madness, you can use termwiz made by Wiz for WizTerm. Yeah, but what's the fun in that? We have to parse the ANSI codes, or else we're not real terminal emulator developers, you know? All right. So if we are in the row state, column state, In any state, if we see an H, we are finished. If we are in the row state, if we see a semicolon, then we just move into the column state. We are now looking for the column. Otherwise, if it's an ASCII digit, our row is now equal to B. How do I get like go from like ASCII digit to number? ASCII character digit. No, that's not what I want. Like, I'm kind of assuming that there is a... Oh, I think it's probably like usize parse, maybe? Or parse. Parse. Maybe it's string parse? Okay. Is there car parse? So stood car converts a digit to digit in the given radix to a car. I assume that radix is like... I actually don't know. Is this like the like base? Like, is this like base 10, base 20, base 3? Yeah, you can... I think the same, but you can cross-test or read it for the solutions. Oh, that doesn't seem crazy. From digit 4. Ah, okay. So here they're saying that I want a base 10 thing. So I want the other way around. From digit to digit. Rust ASCII character to number. Like, am I crazy? Like, I could just subtract 2 digit. C 2 digit. All right. B 2 digit. Oh, but this is a byte, not a... Okay, fuck it, whatever. We'll just do the, like... We'll just do the bullshit. I'm sure that there's, like, a built-in thing here, but we can just do the subtraction ourselves. 40. 48. B minus 48 as usize. Fuck it. Maybe we'll even write a little function. Where actually, so you want 2 digit. But I want 2 digit for a byte, not a character. I guess you can do like B as car 2 digit with base 10 as usize or something. Yeah, I see. And then you would have to like unwrap this. That's probably fine. I assume, like, what is the byte representation of a car here? Does it even fucking matter? I don't really care. Sure, that's fine. We'll live with it. So now if we're in column state. Well, okay, what is the other else? Maybe we put our parser state into invalid. Remember that row column might be 2 plus digit? That's a really good point. That is a very good point. So what we should do instead is in our parser state, we can put in a buffer of pieces of a number that we've received. And we say self.state. No, here we take in the buff here. Yes, 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 yes. Yes. So here we push the byte into the buffer. Buff.push B. And then here we have to finalize that. So we say self.row is equal to buff dot I don't know, stir from UTF-8 of the buff, expect ASCII digits should always result in a valid UTF-8 string, parse, and then we can parse this into a U size, and then we can say expect digits should always parse as UTF-8, or parse as U size. I guess that's not true because they could be negative, but we don't support negative, so it's fine. It's fine. Cool. And in this case, I guess for now we'll just panic and say unexpected character. You need to check if it's empty. Yeah, that's a good point. If buff is empty, buff.push 1. Good point, good point, good point. Okay, that seems reasonable, and we're going to do something similar for column. So column is also going to have a buffer of shit that we got pushed in. Okay. And it's going to look very similar to this, except it's not going to look for the semicolon. It's going to look for the H, which actually means that this H has to be handled inside, because now we have like possibly like accumulated state inside here that we need to handle. So this is no longer fair. Okay. And this guy needs to do this shit. Okay. So we can, I don't know, make a function somewhere. Function, accumulate. Is CSI even the right thing? Oh, this is kind of fucking crazy. We don't know. We actually don't know if we're in this like cursor position thing until we get the end of the sequence. So we just know that we have... Oh, that's fucked. A lot of these guys have an n parameter. So we should actually call this n and m. Okay. Maybe 1 is fine. And we'll call this like accumulate CSI buff. I don't know. And we'll take in a buff, which is going to be a byte slice. And we will return... We will return what? A number. Okay, that's simple. Simple, simple, simple. Which is just this stuff. Boom. And this is going to be actually taking in a vec u8 so that we can do this push shit. And remove the semicolon. Okay. And then here we say self.row is equal to accumulate CSI buff for buff like this, I guess. Okay. And this is n. And this is also n. And calling these row and column also doesn't make sense anymore. This would be n and m. Because we don't know that these are row and column. Okay. Use parentheses to construct this tuple variant. Vec u8. Oh, sure. Like that. Okay. And I guess also we probably want to set the initial states of these guys to none because like maybe they weren't set and we want to keep track of that. That seems reasonable because like maybe somebody passes in N and M, but if they pass in N and M and then a G, that's like an invalid thing. So we should need to be able to check if we actually got something. That makes sense to me. So we start with these as none. And these are actually, sorry, option usize. Which makes this easier. We don't have to do this like is empty shit. Well, we do, but it just instead we return none. So we can say this is an option usize now. In this case, they got none. Otherwise, they got some. And we're chilling. I think. We start looking for N with Beck new. Yup. And in the M state, we are in a similar situation, except we just do not care about the semicolon. And I guess in all of these, we're not just looking for H. We're looking for like the terminator. So we actually don't have a finished. Maybe our finished state is actually like with which option we are. Yeah, we'll just maybe take in a U8 here, and that will flag which version of the CSI thing we're in. So here we'll say if let CSI parser state finished is equal to self state, panic should not CSI parser should not be pushed to once finished. Okay. Here we say it's finished H. And maybe this starts to make more sense as like a match statement. So we match the byte. And if it's H, can we like say that we want to match H? Oh, yeah. We can. So no, I like the if ladder here, I think, because we can do stuff like is ASCII digit. Okay, so here we just push the finish with the byte. There we go, that makes sense. And maybe we'll make a function is CSI terminator. Yup. And this will return true or false. And we can just say B equal match B. And if it's H, return true. Otherwise, return false. And then here we just pass in the rest of this. It's A, B, C, D, F, G. A, B, C, D, E, F, G, H, J, K, S, T. Jesus. We just won't support these ones for now because this seems hard to deal with. Okay, so this is what we have right now. And we'll just go through each of these and turn them into byte strings. Oopsies. So how do that? Record a macro, B, thing, or there we go. Works enough for me. Okay. suggestion of using like BA, BK, which I guess makes sense, but I think I'm okay with just like enumerating them. I think that's fine. I'm okay with that. This guy's saying that he cannot apply equals equals because this guy doesn't have equals equals here. But also I don't want equals equals at all, so that's fine. That's fine. Hello, hello, welcome. Okay. So this guy now has to have a buff thing associated with him, and this is going to go to fit. Both of these guys are going to call the same is CSI Terminator. So if is CSI Terminator B, finished B. And there's like some duplication between these guys, but not enough that I'm worried about it. And here we'll just say this is unreachable because we should have panicked above if we were in the finished state. And I wonder if we're chilling. We never use this invalid state, so I'll just delete it. We're just crashing our program instead for now. This guy needs to be a borrow, which means that this stuff doesn't work because they're trying to take in the vector, but we actually don't need to anymore. This can just be a byte slice. And that makes everything easy. But we need to do mutable here. Nice. And they don't like the returns here, which is fair because there is no option but to return after this. Sure. Okay. That works for me. Okay, so we have this CSI parser now, which is very testable and we should test it. But for now, we just won't because we're lazy and we'll just write fix me UT please. And hopefully that means that off stream I'll see that and remember to do it. Okay, so now we have our like CSI parser here. So he needs a CSI parser new when we set the current state. And now he has the parser in here. And now we can just say parser push B. Say please be mutable. Do I have to mute here? Cannot move out of mutable reference. So here he's probably just mutable by default now. Nice. And now we match the state. And if the state is CSI parser state finished, and it's an H, we know that that is a sequence requesting that we move this cursor position. So maybe our output isn't just ansi, it's like set cursor pause. Okay, and he has X usize, Y usize. Yup. And that makes sense to me so far. And now we just need to make sure we need to like get that in the output somehow. So maybe we say let output is equal to vec new. Okay. And then we have to push this thing in here now. So we say self dot or output push terminal output set cursor pause with X of the parser dot row. Oh, parser n. And Y is parser m. Okay. Chilling. Well, fix me handle on set. Oh, I guess we know what the unset are. So if they're unset, they should be 1, was what the spec said there in Wikipedia. So we can just say unwrap or 1 for each of these. Okay. And in the other cases, we just do nothing. We don't give a shit. And now, when we start an escape sequence, we say output.push data output, and data. Can we do something like data output.take? So that the data output's still valid, but we take all of the useful shit out of him and put him in our output as terminal output data. Yeah. Yeah, and then we just return the output. This is also very unit testable, so UT, please. But I think we're chilling. So we're close. 260, we have a leftover ansi, so we'll just say set cursor pause. And we'll take in x and y, and we'll just panic still and say need to set cursor position to x, y. And let's see what happens. So hopefully what we should see here is when we type clear. Okay, so first of all, something's fucking busted. So we're not receiving any data at all here, which is bad. So what do we do here? We are in the output state. Oh, we only ever push to the output if we're in the if we hit an escape code, but we also have to do it in the end, right? So we have to do it down here. So say if data output is empty, do this. Take the data out and append it to the end. And we don't even have to do the std mem take anymore. We can just say data output. Okay. Okay. So hopefully now, okay, normal case is still working. And if we type clear, CSI parser should not be pushed to once finished. So in the finished state, we have to set our current state to empty. Here, self current state equals ansi builder empty. Okay, let's try it again. Try it again real quick. CSR parser should not be pushed to once finished. What am I missing? Oh, because we push. Yeah, I'm missing something. Because here we push to the parser. We should enter the finished state, and then we should immediately kick ourselves out of there. And that's not happening. Can we print line what we're getting here? So let's maybe print the byte as hex here. Just for everything that we get in here. Not found. This. I see, feels like... So, this actually means nothing to me. Can we print this as ASCII? Somewhere we converted to ASCII, and I've already forgot where that was. Car from digit, was it? No. What was it? I guess we should do like B as char. Seems like it might work. There was something that was like, oh, it was something from UTF-8. Okay, here we go. So we got a $sign and a space, and now we can print clear. And here we get our escape sequence, followed by an H. B, open, then J. J gets set to finished. So Here we don't handle the other escape codes. That's what it is. And here we can say print line unhandled escape code, and we can maybe take the code in here. And yep. How did we there was some function that we called earlier that converted a Rust digit to string from either to. It could have been this car from either to. Yeah, this looks like what it was. So this was stood car from U32 escape as U32. That sounds a lot like what we did earlier. All right. So now when we get the J, we should see unhandled escape code J. Nice. Nice, nice, nice. And then down here we get need to set cursor pause to 1-1. So I guess we parsed the whole input that had multiple escape codes. We got the one that ends in H, which is the set cursor pause, the one that ends in J. And then we panicked because we're like, well, somebody asked us to set the cursor pause to 1-1, and we didn't know how to do that. Okay. Seems reasonable. Seems reasonable. So what's kind of interesting here is before we were storing our cursor position relative to all text that we've ever received. But based off of the fact that clear is telling us to go to 1-1, I guess we should look at what the J thing is. But it seems to me like it's kind of saying the top left of your current viewport is 1-1, is what it sounds like. And the bottom right is probably just like width height. So J, erase and display. Clears of the parts of the screen. If n is 0, clear from the cursor to the end of the screen. If n is 1, clear from the cursor to the beginning of the screen. If n is 2, clear the entire screen. If n is 3, clear the entire screen and delete all lines saved in scrollback buffer. I like this. This feature was added in for Xterm and is I thought I saw the word supposedly supported by the term. Okay, that just makes sense. Okay. Cool. So we just have to support this J command then, I guess. But it means that our buffer that we're storing in our like terminal emulator buffer, this should kind of be like a 2D grid that represents our current screen. Maybe, and that means that we kind of need to know like the size of our screen, otherwise we can't do that. Which makes sense, I guess. Because then we can move the cursor around in the buffer and delete relative to it. Okay. So how do we want to handle that? When we read stuff, I guess we keep track of... We need to know our width and height, clearly. Clearly we need to know that. Or we need to know what the terminal thinks our width and height is, which are slightly different. Okay. So how do we do that? We can look at man3 term iOS. There's no entry for that? Wasn't I looking at this the other day? Man3 term iOS. Man term iOS. Am I high? Why is this not working? Man3 term iOS. What the fuck? So in this shell, I can't access it. I also noticed actually that my like diff doesn't have colors. So there's something fucked up about my Nix environment in this shell where I've installed BusyBox. Okay, we just won't worry about it for now. I think that there's one of the many things that this term iOS thing does is lets us set the size of the window. No. Doesn't look like. Term iOS set terminal size. I'm sure I've seen this somewhere. Maybe it was in this guy. Resize. Sig winch. That sounds familiar. Sig win change. Sig winch. Where does this come from? Sig winch. Maybe look at sig winch on here. Sig winch. Yeah, it doesn't find. Oh, resize term. What is this? This is. Oh, this is from ncurses. But who tells me about sig? Oh, TTY octal maybe? Okay. Get and set window size. Ah, here we go. Window sizes are kept in the kernel, but not used by the kernel. The following constants instructors are defined in sys-octal. Terminal ioctal set window size. No, because this is called get window size. I wonder what this stands for. Terminal ioctal struct window size. Oh, I don't know. I'm just high. This is get window size and set window size, and it's just like the header is fucked up here. Okay. So we execute an ioctal on our terminal handle, and we can ask, what do you think the size is? And we should probably set that to something based off of what our GUI size is. But for now, let's kind of just work with what it believes to be true. And we can adjust later. So I guess theoretically, somebody could resize the terminal without us responding to it. And we actually see that sometimes, like, if I go into this page here, like, oh no, these guys do respond pretty aggressively here. But like this window here on the right isn't choosing the size, if that makes sense, until it's active. So there's something there about like displaying versus setting. Like we can't assume that what we set is what is true for the width and height of the thing. Okay. So maybe we say function get size, get window size. Okay. And he returns like a width and height. That should be something named because it's just a little nicer that way. So you can just say what, like struct win size has like a width and a height. Okay. And he should execute an ioctal, which we should have. Oops, wrong thing. So Nix in docsrs should have ioctal. Nice. He does, and we have to enable the feature ioctal. So you can go to cargo, toml, and enable the feature ioctal. And does he have the like definition of that structure that we saw? Well, I already lost it. Fuck me. It was in TTY octal here. What was the thing? Get window size. So do we have like a win size in here? Oh, nice, we do. Okay, so he's already handled this for us, which is nice. So we need the feature term now as well. Let's get that. Okay. And so we, I guess, create a Nix win size. Oh, that's funny. We actually happen to name it the same thing, which I guess makes sense. So maybe we just don't define the structure and we just use the Nix one. So this is P2I win size. And where's ioctl? Sys ioctl. Okay. So we execute an ioctl on our file descriptor. It's probably not self-fd. Oh, it is. Self.fd as rawfd. And what are the inputs here? This library provides several ioctl macros for binding ioctls. These generate public unsafe functions that can be used for calling the ioctl. What if I just want to call ioctl manually? I guess it doesn't let me. I see. So here, maybe I want to make an ioctl read. Yeah. Okay, so we define our function, which is like this. Ioctl read. And this is read terminal window size. Okay. And we have the name, the type, expression. I don't feel like I have two things here. I feel like I have one thing. What is this, like, magic? Also, why is my maze dead? That's not good. How will you guys stay engaged if the maze isn't running? That would be a problem. Okay. So there's like a magic, and then I see it's declared here. So we need to look for the definition. Ooh, okay. For Linux is documented here. Okay. Fuck. T2I. Can we look for man for T2I ioctl? Fuck, wrong window, because we can't have mans here. So we man for T2I ioctl. And we want get window size. So I guess what we could do is we could get a shell with playing D in it, then try to use that thing and jump to definition. We can see how it's defined, which is a really fucking roundabout way to do this, but you know, it is the way it is. So we look at including sys ioctl.h and include term ios.h, and we just try to use tc what is it? gwin TIOC gwin size. Okay, what is this thing? This is just like straight up. This isn't defined as like this thing. (0x54) is to make these relatively unique t. Oh, okay. So the first. So this is going to be t and 13, I guess. So this is IORT 0x13. Yeah, okay. So what is this guy saying? That the magic is the letter. Yeah. Okay, cool. Cool. So we want to... Okay, first of all, is this really... Is there not like a different way to do this? Win size. Yeah, it does seem like this is what we have to do. Okay. So we can go back to our terminal emulator, and our ioctl read is going to have the T as our magic, And then G win size 13 hex as our other thing. So this is like this. And then he wants the arguments, probably, of data. Yeah. So here our data type is, what was it, win size? And do I have to specify the pointer type? Yeah. Do I? Do I? He says that we pass U8 here. So we just say win size, I guess. And then we can say read window, read terminal window size. It should be defined with the file descriptor and a win size. So we can say let mute win size equal to win size. Maybe we do something like this. Zero it out. Yep. And then we pass in this guy as like this. Cannot find function. So what the fuck was the point of that read, ioctl read? Ioctl read is not found. So do we need to use ioctl read like this? Nice, nice. And then we return win size. Like this. And we have to unwrap this in case it fails. Nice. That's actually sick. How far did you get on the fuse-based project? We got pretty far. It like basically works. Yeah, we got to the point where we could like create items and relationships pretty easily. We had like symlinks sitting around between different items. It was working pretty well. Enough that I didn't feel like it was interesting enough to work on stream anymore. You know, kind of like just like clean up stuff left. Or more of the similar features that is kind of boring to watch. Okay, so we've got our window size. And what do we do with that? We use that in order to figure out how much to buffer. Are you going to use it yourself? Yeah, definitely. Okay, so we now know what the width and height that the terminal thinks that we are at is, I think. Well, let's just maybe print that and see if it's sane. So maybe we'll just like hook in here. And we'll just every frame print it out. And we can say win size dot, what's on this thing? Am I high? What's in this? Row call x pixel y pixel. What does that even mean? And for tty ioctl. G win size. Oh, it just like, okay. So we have row, column, x pixel, y pixel, and these are just unused. So I guess maybe those were supposed to be like, if your x and y pixels were greater than 1, maybe your pixel size was bigger than 1 or something. Who knows? But we should say here that the print line terminal emulator size is this by this, and we can say win size dot, I already forgot, was it rows? And win size calls. I already forgot. We'll see. No cargo check. What is it? WS call. And this should be WS row. Okay. So if we run our terminal now, do we see on every frame no TTY? Okay. Interesting. So it doesn't think that our file descriptor is a TTY? So maybe the TTY is on the other side and we are a PTY. And how do we read that back? Fuck, man. Read PTY size. Yeah, this is surprising. I would have thought that this would work, but it's saying not a TTY, which makes sense if the file descriptor is a PTY, not a TTY. Man, PTY ioctal, maybe? No TTY on PTYFD. I don't know. Okay, yep. Can I run like ioctals on PTY? I feel like I don't get something. Get and set terminal attributes. Okay, get and set window size. Window sizes are kept in the kernel but not used by the kernel. Yep. So, am I allowed to set the window size? I feel like I'm missing something. Because it seems like, based off my current understanding, I see no reason why this wouldn't work. Because, like, we get this file descriptor by running fork PTY. Man 3 fork PTY. Oh, fuck, it's this fucking shit again. Man 3 fork PTY. So it returns file descriptors for the master and slave, blah, blah, blah. So how do I know, like, man is a TTY? I think I've seen that before. So can we look at in the Nix docs, is a TTY function available? Fuck. Is a TTY. Okay. So if I say print line, we'll say here, maybe we'll do it after this. Spawn shell. Print line. Nix unistd is a TTY FD as raw FD. Is TTY. So this, based off what we just saw, should say no. Even though I expected up until this point to say yes. I thought that we were working with a TTY here. Oh no, it does say. So it thinks I am a TTY. Then why is it failing to get the terminal, the window size? Very interesting. Very interesting. Man to, what is like, maybe we go back to man for TTY ioctal. No, for no TTY. Inappropriate FD. So maybe we can't get the window size from our side? That would maybe make sense, right? They're like, why the fuck are you trying to get the window size? Fucking set it, I guess. It just doesn't make sense. Window sizes are kept in the kernel, blah, blah, blah. Is it possible that I've fucked up my ioctal in some way? Like, ioctal read. What does this do? Generates a wrapper function for an ioctal that reads data from the kernel. Uh, is there a way for me to just like call ioctals without fucking doing this? No. Ugh. Ugh, ugh, ugh. Bump. Ugh, ugh, ugh. Ugh, ugh, ugh. What is the ioctal number? It's like, so the Rust, or not Rust, sorry, like the kernel just says like, hey, I am a device handle, and you're gonna call me with this like IO control, and you're gonna say IO control 125. And that's like, I'm gonna like look up a function associated with 125. And so they define functions and they like just define numbers for them. And so like the ioctal number is supposed to be like our way of communicating to the kernel that this is what we're trying to do. So we're saying like, hey, I'm trying to call terminal emulator function number 13. And if we go into our like, what's the name of the octal we're trying to use? Oh, I see. We're trying to use TIO get win size, G win size. TIOC get win size. I guess I should double check that 0x54 is in fact capital T. 0x54 should be capital T if I understand correctly. Yep. I guess we should look at like what this IOR thing does. So he calls IOC, where this is shifting by NR shift, which is 0. Makes sense. So we're passing IO read type number. Yeah. So it should just be that. And then they just, what is this like size check? Whatever. Whatever. Maybe this does matter. We could try, let's try dodging this in some way. Is there a way to just call like, does the libc crate have just like a raw ioctal thing? Yeah, it does. So let's try using that instead, just temporarily. So cargo add libc. Then here, instead of this, we're going to comment this out. Maybe we won't. We'll just say libc ioctal. And we'll use this, and we'll just punch in the number manually, which was 0x5413. And pass in mute win size. And if ret is equal to -1, try ioctal read bad. Oh, is that what those bad ones are for? Because there's supposed to be some size type checking and it's just not doing it. That seems kind of possible. This will give me the same answer. This will give me the same answer. So if I run this, if it does not crash and we get a valid window size, it does say 0x0, which is a little concerning. So can we look at maybe, can I not zero this out? Win size WS row is equal to like 11, and it's WS call is equal to 11. And if I run this again, if it gets set to 0, 0, then it just means that it thinks that we're at 0, 0. Oh, okay, that's not bad. Okay, yeah, so I think you're right. I think you're right, because they're not type size checked, which we just discovered. We had just made it there with this like IOC size shift. Okay, yeah. So this ioctal needs to be defined with ioctal read bad. And now we should be able to call this guy normally. And now I guess they want like 0x5413 here instead of the magic shit, which also makes sense. Hell yeah. Okay, that's making sense now. At least we're not crashing. Now it does think it's 0, 0. So that's kind of surprising to me that like any like the clear command, I guess the clear command doesn't really care about the window size. But it also means that like the terminal client thinks that it's 0 by 0. So how can it, like if we're trying to represent what it thinks, then that's not really reasonable. So I guess Joey is watching and saying you need to set it first, which makes sense. But I wonder how software is like expected to behave in the 0x0 case. Like the fact that when I start nvim, oh, well now he's crashing because he's seeing unexpected characters in our parser that he wasn't before. But before he was like showing something, which is kind of surprising. Maybe they just pick like a default size in the application themselves if they don't care. Okay. Well, I guess for now, we can set some size from the GUI. So maybe on each frame, we could maybe just say like self.terminal emulator set size, and we need to calculate the size somehow. So how would we do that? How would we do that? Maybe we're getting distracted. We don't have a ton of time left, so maybe we just want to make sure that we get to somewhere where the clear command will actually do something. We have 35 minutes, so maybe we just ignore this for now, and maybe we pretend, say we pretend that our terminal is infinitely large and infinitely wide. Then, when we set the cursor position, we can store all scroll back forever. And when we set to 1, set the like size, the cursor position to 1, 1, we can just set our cursor position. Like this. Right? Yeah. That seems reasonable. And so when we run clear now, we should see the cursor end up in the top left. Close. 1, 1 is not where it's going. Okay, let's get rid of this shit first for a second. This is annoying. So let's see. So when we run clear, it could be that we're immediately moving the cursor again after. So maybe we should print out what we get back from this push. Output buffer push. So can we like, maybe we'll say print line moving cursor here, and here we'll say setting cursor pause to XY. Okay, and maybe then when we retrieve the cursor position, we'll print it. Retrieved cursor pause is self cursor pause X and self cursor pause Y. Let's just kind of see what the fuck is going on. Okay, so we move the cursor, then the retrieve cursor pause is 0, 1. Then we get some shit, and we set the cursor pause to 1, 1. Then we move the cursor. What is moving cursor? Ah, I see. Maybe we're gonna say update cursor. We'll say moved updated cursor to this. And we can print out self.cursorPause x self.cursorPause y. We can see where it is after we move it. In bash source code, if all else fails, default to an 80 by 24 terminal. Oh, that makes a lot of sense. That also lines up with what we were seeing, which is interesting. Okay. So if I clear, I set the cursor pause to 1.1, updated cursor pause to 1.1, updated cursor pause to 3.1. So where are these updated cursor pauses coming from? Maybe we should see why. Due to data this, and we can say stood stir from UTF-8 unchecked because I don't really care. That's not really valid, but you know, we'll get away with it. What does it want me to consider borrowing here? Here? All right. All right. I just want to see what's causing the movement. Due to data $. Oh, so after the clear, we got a new $sign thing and like a new prompt line, and we're off by 1. Okay. So 1, our cursor position should be initialized to 1.1, not 0.0. So where do we do that? Or we leave the cursor position in our thing as we like it 0 indexed, like normal programmers, and we can subtract 1 here, which should make sense. So now when we run clear, our cursor is now at like the correct spot, but we just didn't do the clear. Okay, that's sick. And so now all we have to do is we need to parse the clear command, which is simple. We're like very close to having that actually. It's just when we have our finished state, we need to look for clear. Which is J. J for clear, you know? J for clear. And all we have to do here is we just have to delete everything according to N. So maybe we will say terminal output, and we'll make a clear forwards, clear backwards, and clear all. And we'll just ignore this. We'll map the scroll back one to clear all as well. Okay, so here we should check. So we should say we'll assert for now, which is not really correct. Crashing here is stupid. But for now, we'll just do it this way because we're debugging, and we'll say assert that the M of the parser is none. Right? We should only have gotten one parameter here. And the N parameter, we'll unwrap it because we're getting lazy again. We'll say let, I guess we just match this. Right? And if it is, oh, it could be missing. Unwrap or 0. J for just clean everything. I like it. So if it's 0, we go to ansi builder. Nope. Terminal output. Clear forwards, I think they said. 0, clear from cursor in the screen. 1 is clear backwards. 2 or 3 go to clear everything. Nice. Nice. And anything else will, again, panic unhandled. And here we should say fix me. Fix me. What does the fix me? Should fail gracefully. Okay. And then we just say output push red. Okay. And then we have to set the parser state to empty in this case. And I think we're chilling. So I guess this is surely just complaining that we have to handle that now. So here we'll just handle clear forwards, clear backwards, and clear all. So clear all is easy. We just clear the buffer. Clear backwards. We take the cursor position, which we actually need to convert into a buffer position. So I don't know if we have anything like that right now. Update cursor, set non-block. No, okay. So we'll do, we'll make a function here, cursor to buffer position. And this is gonna take in the cursor pause as a cursor pause, and a buff as a bunch of bytes. He's gonna return a usize, which is an index into the buffer where this cursor is like related to. And we're gonna split the buffer by new line. Okay, so now we're gonna have lines. So the outer iterator is lines. And we're gonna skip cursor pause y. And next. Does this make sense? We also need to enumerate this. And make our thing is like this. Split is available on U8. Oh. Is split, will it give me the indexes? Because I want to know where I've split at. Okay, well, we can do this. We'll take the split and we will find the start line. Line start is equal to this. And we will take the number of lines that we expect, right? And we will accumulate the sizes of each of these guys. So what is like the take on an iterator? Why is that not working? Split, slice, split. He's an iterator, is he not? Impl iterator, yeah. And is take not a method on here? Take size n, okay. So what the fuck is he bitching about? What is he complaining about? So maybe we need to do b is equal to this for this to work. Nice, okay. So we have this, and we just say like accumulate. There's some like fancy math word for the accumulate here. I can't remember what it is off the top of my head. Filter map reduce. Is it reduce? Reduces all the elements single one by repeatedly applying a reducing function. Fold also sounds right. Fold every element into an accumulator by applying an operation. Doesn't really, I guess reduce is fine. So this takes in a and b, and we just return a plus b. A.len plus b.len. So this will tell us where the line should be. Okay. Oh, but this doesn't, okay, we do need to do fold. We do need to do fold because they expect something like that. Need to specify. A should be like, this should be that, yeah, like that. This should be accumulator item. And we want to turn ac plus item len. There we go. There we go. Cool. Works for me. Or you could do map x.len.sum. Yeah, that's true. I think I'm okay with this. This seems fine. Okay, so then we have line start plus cursor pause X. And I think that's the position in the buffer. Cool. And so now we can say that the cursor to buffer position takes in self cursor pause and the buffer. And we just delete everything. So we say what? The self buff is equal to self.buff from buff pause onwards to vec. And for clearing forwards, we do everything up to buff pause. All right. Sure. I don't know if this is quite right. I don't know if they expect like to be filled with empty spaces or to be like completely gone. So fix me, write a test to check expected behavior here. Might expect existing content to stay in the same position. Okay. Position. Okay. But I think now if we run this, I think it works. Maybe. Maybe. Maybe not. Hell yeah, baby! That's so fucking sick. Let's go. Hell yeah. Backspace doesn't work. But clear fucking does. Let's go, baby. That's pretty sick. That's pretty sick. Okay. So I think we made a lot of good progress here today. What did we even do? Where did we start? We started with something that didn't handle ANSI codes at all, and we built out this like ANSI parser, which I will just rename to ANSI parser right now. And he like looks for this like escape code somewhere. We probably lost it. ANSI Wikipedia. So he looks for this like escape code, and then he finds that like we got the escape code, and then he says, "Oh, what if we get this guy? We're in a control sequence parser, and then we have our control sequence parser that looks for like this general pattern of CSI n semicolon m followed by some terminator, and we now handle the like cursor position and erase in display variants of this guy." So we're still missing like a hell of a lot, but we do have enough to implement the clear command, which is pretty sick. Pretty sick. What else we do? We looked at like the window size stuff as well. So we added an ioctl that retrieves the window size, but that doesn't do jack shit because our window size is empty, but we did explore that a little bit. Yeah, pretty happy with progress today. Pretty happy. That's pretty sick. Bro, what the fuck is a parser? I'll be honest, I feel like I don't really know. In my head, when I say parser, I'm thinking, take input, turn into thing I can use, right? So we have like sequences of inputs that like switch based off of what you saw before. And so usually you see people talk about like lexing and parsing, where lexing is being like, oh, I know what that character means. That character is a comma, and comma means separator. And then parser is like being like, okay, I have like a thing, then a separator, then another thing. I'm gonna like put all those together and call those like a function or something, right? So I don't know if that's like, if I'm using the word correctly, but in my mind, that's what it means. Yeah, I think I'm gonna call it there for today. There's some extra work here to be done for sure. I need to like unit test some of this stuff. This stuff is like so fucking easily unit testable and so easy to get wrong too. So it's the kind of stuff where it just makes sense to bang out some. And we have to like fix all of the places where I was like panicking and unwrapping and like just crashing the application. We get unexpected input. We should handle that a little more gracefully. But I think like the core of what we wanted to accomplish is there. And so it's pretty cool. Pretty cool. Thanks for watching, guys. If you liked what you saw, I stream most days around 1 or 2 o'clock Pacific time for somewhere between 1 and 2 hours. If you miss a stream, there's a YouTube link in the Twitch description, and there all the VODs go up. And if you're watching on YouTube and you want to swing by on Twitch, say hi, talk in chat. There's a Twitch link in the YouTube description. In Twitch, there is also a GitHub link and a Discord link. So the GitHub link will have like this code in a like probably slightly prettied up form. Go up there soon. The project does exist in some form today, but it's only got like an initial commit. And the Discord is there for if you want to like, I post like announcements a little ahead of time when I'm going live, as well as like when VODs go up, and people chat in there about like programming shit. So if you want to swing by, that's there. Do I have anything else to plug? I don't think so. Thanks for watching, guys. I'll catch you on the next one. Bye!